welcome to WOW TV. My name is Angel, and I'm here from the Wizards of Wright program. The WOW program is a part of the Educational Outreach Office here at Wright-Patterson Air Force Base. Today, we're going to do some fun activities and make a few things that you'll get to keep when we're finished. Are you ready to get started? Let's go! Today, we're going to talk about a special kind of science called chemistry and learn some new words. Chemistry is the part of science that studies what everything is made of and how it works. Cooking is a form of chemistry. So is making ice. Medicine is the result of chemistry. So is paint. Chemistry is all around us. Have you heard this science word? Matter. Matter is anything that takes up space and has mass. Everything around you is made up of matter. Chocolate cake is made of matter. Your desk is made of matter. You are made of matter. And all of these things, these pieces of matter, are made up of atoms. Two more chemistry words that we're going to learn today are monomer and polymer. A monomer is a single atom or molecule that makes up something. Think of it as one paperclip. A polymer is when we link a bunch of monomers together. Now, imagine we've connected several paperclips into a chain. In chemistry, we call that a polymer. You actually use polymers every day. Plastic is a polymer. Some of your toys are polymers. You probably already used a polymer today. Teachers, we'll pause for a few minutes while you and your students look around your classroom and find some things made of plastic. I'll meet you back here in a bit. Did you find a lot? Did you notice that they can be used in different ways? You know, our bodies make polymers. They're called proteins. And just like some of the polymers we've seen in the room, the polymers in our body do different jobs. For example, there are polymers or proteins in our hair, our fingernails, and even our saliva. Different polymers have different properties. Some are stiff, some are flexible, and some are even in liquid form. As I mentioned, polymers can be used for different things. Let's build an example of a polymer together. We're going to use beads and a pipe cleaner. We will pretend our beads are a monomer unit or a single unit, and we'll string them together to make a polymer. Teachers, will turn it over to you while they make their polymer chains. Each student will need to thread 8 beads onto a pipe cleaner. You may need to help them tie off the polymer chain at the bottom so the beads don't fall off. I'll meet you back here when you're ready. Did you make your polymer chains? Let me show you something. Some polymers can be linked together to change their properties. We linked these pipe cleaners together to show you how some polymers link together. The white pipe cleaners are our polymers. And when we add a certain chemical, the yellow ones, it causes units to link together and change. Let's take this example and give you the chance to cause a change. You're going to perform a chemical reaction to make a change. Remember, there are 3 states of matter: solid, liquid, and gas. You're going to change a liquid polymer into a solid. Your teachers are going to help you make this polymer, but before we begin, let me give you a really important direction. After you receive your mixture, do not open the baggie. Teachers, let me show you what you'll be doing. Each student will receive a baggie, and in it you should add 1 ounce of the PVA solution and 1 teaspoon of the borax solution. I've already got my borax in here. Let me add the PVA. And you can also add food coloring at this time if you want. Make sure to seal the baggie before handing it to the students. Students, it's your job to knead the bag, to mix it, but remember, keep it closed. Then watch for the chemical reaction. The liquid polymer will become a solid polymer. I'll meet you back here when you're ready. Were you surprised by what happened? Chemists design polymers to serve specific purposes. Here's another example of a polymer designed to do a specific job. Now, I know you know what this is used for, but do you know how it works? Let me show you. The outside of a diaper is a polymer. It's plastic. There is adhesive up here, a different kind of polymer. and inside a padding. We know that the goal of a diaper is to absorb liquid. Let's see how well the inside padding does. Let me get some cotton balls. Well, that's not doing it. What does absorb the liquid in a diaper? There is a specific polymer in the padding that is used to absorb the liquids. The powder in this baggie is called sodium polyacrylate, and this is the only part of the diaper we need. Take a moment and think about how much water you think this powder might be able to hold. A teaspoon, a tablespoon, a few ounces? Let's see. Isn't that amazing? Let's put in some more. Teachers, let's pause so you can do this experiment too, and when you're finished, set the bag aside so you can use it at the end of our lesson. Remember what we said earlier? Chemists design polymers for specific jobs. Even if we have the same materials, how they are prepared changes their properties and the job the polymer can do. For example, do you know what this is? Yep, that's a packing peanut. What about this? A CD case. They're both made of the same polymer. It's called polystyrene. Let's look at these different test tubes. The same material is in these tubes, but the chemists prepared them in a different way. As you can see, one floats and one sinks. The packing peanuts are manufactured by blowing them with air, like cotton candy. When used like this, they float because there is more air in them. In its more solid form, the same material sinks. Teachers, we can pause for a few minutes if you'd like to pass the tubes around. Let's get ready for our next activity. I'll place an empty jar on the tray. I'll pour a small amount of acetone in the jar, 100 to 150 mils. Acetone is a liquid that is used in chemistry to break polymers apart. It's also used at lower concentrations to remove nail polish. Teachers, we can pause here while you do this experiment with your class. You might want to ask them to hypothesize or predict what will happen to a packing peanut once it's dropped into our chemistry liquid. When you're finished, please use the jar marked for the used acetone. Were your predictions correct? Let's go back to the diaper demo and see how that powder has gelled up. Teachers, if you want, you can pass that around now too. When you get it back, here are some things to review from today. Polymers are all around us, from the utensils we use, to bags and diapers, to airplanes and rocket ships. Polymers are designed to do different jobs, and as we've seen, the same material can do different things. You all did a great job today. Thanks for joining me. Teachers, thank you for using this WOW lesson, and please check out more at our website at wpafbstem.com.